morning, everybody. I'm Chris. I work on the Fabric Customer Advisory team at Microsoft. And I'm here to talk about, what I think is one of the hottest topics in Fabric. If you've been at SQLBits already for a couple of days, you might have seen my colleague Phil Seamark did 2 sessions on this already. If you notice any slides that are similar, he stole them from me, all right? And I think somebody else did a Direct Lake session. So, hopefully you didn't go to any of those, because I'll probably be covering a lot of the same material, especially with Phil, because he stole my slides. But this is fun. This is important. You know, you hear some negative people out there. Nobody comes to SQLBits as negative, but you do hear some kind of negative people out there on the internet saying, oh, yeah, it's Fabric. It's just repackaged Power BI, repackaged Synapse. You know, it's just the same old stuff over again. Direct Lake mode, stuff we're going to talk about today, this is new. This is the real deal. This is exciting. This is the stuff that has our competitors worried. It's the stuff that has some of our friends worried as well, because it's so cool. So, what are we going to talk about? So, we'll understand what Direct Lake mode is, obviously. We'll talk about what you need to use it, why it's a good idea. We'll talk about some of the limitations, because we need to be honest about what it can and can't do. And then towards the end, we'll talk about some of the internals. First of all, what is Direct Lake mode? If you're doing BI in the Microsoft world, you will have an architecture that probably looks a little bit like this. I've been doing Microsoft BI for a long, long time, and ever since I can remember, people had architectures that looked a little bit like this. You had your source data, which was in all kinds of different forms. You maybe did some ETL on it. You created a star schema. You put that star schema in a relational database. Old days that would have been SQL Server. Nowadays, it might be Synapse dedicated pools. It might be, God forbid, even Snowflake or BigQuery or something. And then you put your semantic model on top of that inside Power BI. That's the way things have always been. Now, when you created your semantic model inside Power BI, you always had 2 choices for storage modes. 2 fundamental storages. You could mix and match them a little bit, but you had to make the choice between import mode and direct query mode. Import mode was the default. That was the choice that we at Microsoft always encouraged you to use. That was the choice that 95% of the time people did choose. With import mode, you took your data from your data source and you copied it into Power BI's own in-memory column store database engine, the Vertipack engine, inside your semantic model, what used to be called a data set. That copying was called refresh. And when the data was inside your semantic model and you opened up your Power BI report, the Power BI report generated a DAX query per visual. The DAX query ran against the semantic model. The semantic model contained all the data you would ever need to see inside a report, and it returned the result back to the report, and you saw your report. Import mode was great. The reason we told you to use import mode by default was because it gave you the fastest report performance. It gave you access to all of the good stuff inside Power BI. So we always said, use import mode. The other alternative was direct query mode. In direct query mode, you still had a semantic model, but the semantic model didn't contain any data. So when you as an end user opened up your report, the report generated DAX queries against the semantic model, but because the semantic model didn't contain any data, the semantic model then said, oh, okay, I need to get some data from the data source. So it would generate queries against the data source. Most of the time, those queries would be SQL queries, not always. Not all data sources speak SQL, but the semantic model would generate queries against the source, get the data that it needed, pull that back to the semantic model, stitch it all back together again, return the results of the DAX query, and your report ran. Now, this sounded great in theory. Sounds great in theory still today because, hey, you're not refreshing. You're not copying any data across. The downside of direct query mode is that it tended to be slower. Why is it slower? Well, because you've got a bit of latency. You've got to run the query against the semantic model. The semantic model has got to translate that to one or more SQL queries. Are those SQL queries optimized? Maybe, maybe not. How many SQL queries are being generated? How many round trips have got to be made? How much work is going to be done in the semantic model to stitch things all back together again to create the result of that DAX query? Well, you know, it got very complicated, quite difficult to tune. You can make direct query mode work well today, but you need to be an expert on your semantic model, and you also need to be expert on tuning whatever your source was. Direct query has got some advantages, and import mode has got some disadvantages. The other problem with import mode is that you can only store as much data you can hold into memory in import mode. With direct query mode, because you're not storing any data in the semantic model, you don't have those limitations. The only limitations are how much data you could store in your data source. So there were some trade-offs, but most of the time we said use import mode. The architecture changes when you're using Fabric. Because with Fabric, you get your source data, and now you copy it into one lake. Store it inside a lake house or a warehouse, and then you can put Power BI directly on top of that. And the interesting thing about Power BI, if you start playing around with Fabric and doing the demos, you copy the data into, say, a lake house, and you can just start building Power BI reports on top of it. It's kind of magic. And this is the magic of direct lake mode. So direct lake mode is a brand new storage mode inside Power BI. It is something genuinely new. It is not import mode. It is not direct query mode. The thing that people get excited about with direct lake mode is that it gives you fast query performance, almost as fast as import mode, but not quite. But you don't have the overhead of copying all of that data into your in-memory semantic model, which means that you don't have to refresh anymore, which means you're not sitting around for those refreshes or worrying about how to configure partitions and incremental refresh. It is, I would say, almost the best of both worlds. Best of both worlds between import mode and direct query mode. Why does it give you fast query performance? Well, it gives you fast query performance because when you run your query, the data is got from in memory, kind of like import mode. How does that happen when I said that you're not copying the data into memory? Well, you're not refreshing. You don't have a refresh operation anymore in the import mode sense where you copy all of the data across into memory. What happens with direct lake mode is when you run your DAX query against the semantic model, initially the semantic model does not contain any data. You run your DAX query, the semantic model says, oh, I need the data for this particular query. It then gets that data from one lake and loads it on demand. It only loads some of the model. It doesn't need to load all of the model. It looks at the columns you need for your query, and it loads those columns into memory. So it pages the data in on demand. Isn't that still going to be slow? Well, no, this is where the other cool stuff happens. Because it's like import mode on demand, but not just for just the columns you need. Inside one lake, data is stored in Delta format, which under the covers uses Parquet, which under the covers is a column store format. And it turns out that the format used in Parquet files is very, very, very similar to the format used by import mode to store its data in memory. So what the clever people on the development team worked out was that, hey, what we can do to page that data in super quickly is read the data in the Parquet files, which happens to be in a very, very similar format to the format that we need for import mode, and we just change it on the fly to the format needed for import mode. So it is kind of like import mode refresh, but because the data is sitting in a format which is practically the same format that we need it to store it in memory for the Vertipack engine, we can do that super quickly, maybe in a matter of seconds, which is why we can grab that data from one lake and load it on demand at query time, and load just the columns that we need. So this is how, with direct lake mode, you load your data into one lake, you build your semantic model, you don't need to do a classic refresh, you build your reports, and bingo, the data is just there. Let's just see this. So I've got a Dataflow Gen 2 here, and I've used it to load this table into one lake. Really, really simple table. Not very large. Let's close this. All right, so I've loaded it into a lakehouse, and I've got a sales table inside my lakehouse. I'm going to flip over to the SQL endpoint, and I'm going to go over to model view. This kind of looks familiar, doesn't it, to anybody who's a Power BI developer? This kind of looks like where you would build your semantic model in Power BI Desktop. That's because it is. Ignore these things over here, they're going away soon. But there's your sales table. If I had, what did I click just then? If I had other tables here, which I'll show you in a moment, I'd be able to build relationships. But look, I can see that there is a sales column here, which is numeric. I can build a measure. And I'm going to call it sales amount and some, don't use that. Enter. So that's DAX, undisputably DAX. I built a measure. I've got a measure on my table. And I'm going to build a new report. Ignore that. And let's build a table. Let's grab country and sales amount. And there we go. So that's Direct Lake in action. It's kind of underwhelming, really, because it just works, apart from that error. What we're going to do is spend the rest of this session thinking about what the benefits of Direct Lake are and understanding how it works under the covers. Because like I said, it just works like that. You build your semantic model, you build your reports, and there you are. What do you need to play with this? Well, obviously, you need Fabric turned on. Fabric's not a different thing. If you've got Power BI, you can turn on Fabric. You can set up your own Fabric trial capacity very, very easily. So you can play with this if you've got Power BI already today. Like I said, you will need to go to the admin portal and turn on Fabric. If you're an administrator, you can do that yourself. If you're not, you can ask your tenant admin, or if you've got an existing premium capacity, you can turn that on. You can also limit use of Fabric to certain security groups if you don't want your friends to play around with this cool stuff. But you will need a capacity. If you've got an existing PSKU, that's great. If you haven't, just spin up a trial capacity. Very, very easy. But you will need Fabric. Now, let's think a little bit more, in a little bit more detail about creating semantic models. Because we still need to have a semantic model to use Direct Lake mode. Now, in that demo that I just showed you, I loaded a table of data, or I had loaded a table of data into a lakehouse. When you create a lakehouse, or indeed a warehouse inside Fabric, a custom semantic model, a default semantic model is created for you automatically. That's that thing that I was editing there. So, if you just load some data into a lakehouse, you don't need to do anything else. There is already a default semantic model there with all of your models present. You can, however, create your own custom semantic models using the web-based editor. So I could go back to here, and let's not save that, but let's go back to my lakehouse. Oh, sorry, I've got a SQL endpoint. And I can see that there is a new semantic model option here, which if I clicked it, I could go away and create a new semantic model with a particular name and select some tables that were there in my default semantic model. I'm not going to do that now. But that's how I would create a new semantic model. Something important to point out is that you cannot create semantic models in direct lake mode today in Power BI Desktop. It's not supported yet. Might be in the future, who knows, but you can't do it today. I see people get very confused with this at the moment, but you can't do it. You've got to use the web-based editor, as I was using there, or you can use external tools. For example, Tabular Editor 3, like the nice people downstairs in the hall. I'm sure they will show you using Tabular Editor to build semantic models. Or if you're feeling technical, you can run your own scripts, your own Timsel scripts, and build your own semantic model that way. I don't recommend that. If you are using the web-based editor, it is also worth pointing out that the web-based editor is still a work in progress. There is some functionality there that's available in Direct Lake semantic models that isn't yet exposed in the web-based editor. For example, you can actually set up row-level security roles on a Direct Lake semantic model. It's just the web-based editor doesn't allow you to do that. You would have to use, well, for example, Tabular Editor 3 or your own scripts to be able to do that. Those are things that are coming. All right, what are really the benefits of Direct Lake mode then? First of all, let's think about how long it takes to get your data to your end users. Let's see how long it takes to actually get to the point where your end user can open up a report and see some data. In our traditional architecture, you would start off with your source data. There would be some ETL. You copy and load that into your relational database serving layer. And then, of course, with an import mode semantic model, you would have to refresh your semantic model. Now, you're never going to get away from having to clean up your data and run your ETL. There's no magic sticking plaster for dirty and badly modeled data. So you are going to have to create your star schema still. But it's that extra step of taking the data from your relational serving layer and importing it, refreshing that semantic import mode semantic model. That is where we can see some savings. Because in direct lake mode, you're still copying your data. You're copying it into one lake. That doesn't go away. Turns out that that can be done quite efficiently. And then you just got that on-demand load into your direct lake semantic model, which you don't need to wait for except at query time, which should only take, hopefully, a couple of seconds. So you've effectively taken out that import mode refresh step. So overall, you're going to get the data to your end users faster. And we eat our own dog food at Microsoft, and I've been talking to the person who builds the internal reporting for Power BI. I was saying the other day, we're all spying on you and seeing what you're doing with Fabric and things. He builds those reports. They used to be import mode semantic models. They're now direct lake mode because we want to test to see how this stuff works in production. And he thinks that he's knocked about 2 hours off his end-to-end time just from using direct lake mode without having to do a refresh. This is a clever guy. This is about as good as a Power BI developer you would ever get. Of course, he was using incremental refresh and all of those other tricks to make your import mode as fast as possible, and he still knocked about 2 hours off the end-to-end process. So, first benefit, you're going to get your data to your end users as fast as possible. Secondly, if we think about this kind of architecture, you've got your source data, you've got that serving layer there, you've got Power BI. With direct lake modes, you kind of knocked out that middle section. A lot of people would be quite happy to get rid of an extra layer from their architecture because, guess what? Less moving parts, fewer licenses, cheaper, lower maintenance. Tons of my customers have this dream of saying, well, you know, I've got my data nicely modeled in my gold layer in my lakehouse, and then I've got to pay for this relational database whose only point was to act as a staging layer to load the data into Power BI. Why can't I get rid of it? Well, guess what? Now you can. And you can save some money. That might save some money and mean you end up paying less money to Microsoft, but luckily I'm not paid on commission for selling you stuff. I'm here to tell you what's right. There are some other side effects, some other benefits for this as well. So you're copying all your data into one lake, and you're building your semantic models and things on top of that. When you do this, you get some other stuff for free. Guess what? As we saw earlier, in a lakehouse or a warehouse, all that data you've just copied into one lake, you can run SQL queries against it. So just by loading the data into one lake, you've got SQL querying against your data, which is great. And you can do Python and R and notebooks and other stuff on top of that, all against the same single copy of your data. That's got to be a benefit. Coming soon, later this year, you also have another really cool thing, one security, where you can define, for example, row-level security at the lake level, and then all of your workloads, not just Power BI, respect that security. It's not there yet. There is security. I would like to stress that. I can see Casper looking at me. You can still apply security in your semantic model in other places. One security just means you apply it once, and all of the workloads respect it. So that's going to be pretty cool. There's another thing, which I think is really amazing, with one lake. Shortcuts. So, one lake stores your data in Delta format. You can have lots and lots of lake houses spread around your tenant, where different people load different tables of data in. Shortcuts allow you to share those tables between different workspaces and different lake houses. Now, when you create a shortcut, you are not creating duplicated copies of the data. You are just creating a reference to a table. And you can create a shortcut and make that table appear inside your lakehouse, which means you can use those tables inside your semantic models. What practical use is this? Think about all the import mode semantic models you've got inside your organization today. What's one thing that every single semantic model has got? It's got a date dimension table. How many date dimension tables are sitting around in your organization? Lots and lots of them. Now, they're pretty quick to refresh, but you have to refresh them every time. And maybe everybody's got a slightly different copy of the date table. Maybe somebody's created one, maybe somebody's created another. With shortcuts, you could have one person creating a date dimension table in their lakehouse, and everybody else could create a shortcut to it, which means that they have access to exactly the same table, exactly the same copy of the data for use in their semantic model, which gets loaded once into that central lakehouse, and then nobody else needs to do any more refreshing. So you've automatically saved quite a lot of refresh time and ETL time. And guess what? It's not just the date dimension table. There are other dimension tables. Lots of these semantic models are all going to want to share the same product dimension table. A lot of them might be sharing the same fact tables, which in import mode, God, you'd have to refresh them over and over. Just think about all that duplicate work. With shortcuts, you can like create Lego blocks and fit all things together. Let's see an example of this.
Chris.
So here, can I take questions at the end?
Oh, yeah, okay.
So here I am in my lake house. I've got my sales table. And I want to be able to do a lookup. I want to create a dimension table. I know somebody else in some other lake house has got a dimension table that I want to use. I'm going to create a shortcut. So what do I want to do? I want to refresh that to make sure that that's not there, because I have had some problems with this in the past. Yes. Oh, yeah, that's the point. I'm in the SQL Lakehouse. Thank you, Casper. I'm going to create a new shortcut. And somewhere down here, I have got a shared dimensions lakehouse. Click Next, where there is a table called product category. And I'm going to click Next and click Create. And there is my product category table. So I've not copied it, I've just created a reference to it. And there we are. There's my products, and there's the categories. If I go to my SQL endpoint again, the table should now show up in my SQL endpoint. There we go. We go to model view. I'm going to join product onto products, create my relationship, click OK. That looks good. Build a new report. Ignore that error. And now I can take a column like category from that product category column table. There we go. And take my sales amount measure, and then it all works. So I can use tables that I've created through a shortcut that somebody else owns, shared dimension tables, fact tables that have been loaded in somewhere, and build my own custom semantic models and bring things in. So I think this is a massive benefit. It's going to save a lot of time. It's going to mean that everybody can share the same copy of the dimension table or even the same copy of a fact table. Let's go back down to earth and talk about some limitations. Because there are some limitations which are going to be temporary. There are going to be some limitations which probably stay forever. First of all, if you're building a direct lake semantic model, all of the data you need needs to come from a single lake house or a single warehouse. You can't have a direct lake semantic model that gets data from multiple lake houses. But just to be clear, if you're just pointing at a single lake house, as I've just shown, you can create shortcuts to bring in kind of references to tables in other lake houses. So I don't think this is that much of a restriction, but it is something to think about. Another thing is you cannot create calculated columns or calculated tables in direct lake mode. I'll talk about why this is in a moment. But it means that if you want to add an extra column onto a table, well, guess what? You've got to go a little bit further upstream, add that column in, for example, in a Dataflow Gen 2 or in a notebook or whatever's loading the data into OneLake. Some people on the internet really, really hate calculated columns anyway. Personally, I'm not that against them, but we can't let a session like this go without mentioning Roche's maxim of, as far upstream as possible, as far downstream as necessary. We're just pushing you to do this work upstream. And there are some technical reasons why we can't do calculated columns. Calculated tables, I'm a lot more against. I'm not that much of a fan of calculated tables at all, but you can't do them for the same reason. Composite models are also a bit tricky. We're working on that kind of limitation. Not all data types that you can use in OneLake are supported because the analysis services engine didn't support, for example, binary data types or kind of structured data types. We want you to use a star schema anyway. So again, I don't think this is that much of an issue. And there are also some kind of temporary issues. For example, if you use analyze in Excel against a direct lake model, you'll find that you can't create hierarchies and drill through doesn't work. And there are some kind of teething issues as well. Another thing to mention, which is really important to understand, I wouldn't say it's a limitation, but it's something you do need to understand, is something called fallback. When you first create your direct lake model, you think, great, I'm using direct lake mode, should be nice and fast. A lot of people build their semantic models in they build what they think are going to be direct lake semantic models, and then performance is not as great as they want it, and they think, well, this direct lake mode, it's not really all it's cracked up to be. The answer to this problem could be fallback. Remember, in direct lake modes, even if you're paging the data in on demand, the data still has to be stored in memory. And remember, there's a finite amount of memory. You can't have an infinite amount of data in memory. And so there are going to be situations where you think you've built a direct lake semantic model, but the engine says, well, hold on, I can't actually use direct lake mode for a particular reason. In which case, by default, it will fall back to direct query mode. Because remember, we're sitting on top of a lakehouse or a warehouse, we've always got the ability to run SQL queries. So it could always fall back to direct query mode and run some SQL queries, and then get the result back. So this is what we mean by fallback. Fallback is just the ability, or the default ability, of a direct lake semantic model to say, hold on, I can't actually use direct lake mode. I'm going to fall back and become a direct query semantic model. A couple of situations where this might happen. Now, we've made some changes recently to kind of make these issues harder to run into. But for example, if you've built views inside a warehouse, you can't build a direct lake table on top of a view in a warehouse. Why is this? Well, think about how direct lake mode works. Remember I said with direct lake mode, you've got your delta table, and we're paging the data in super quickly into memory. What's a view? Well, a view, if it's not materialized, is not a physical thing. It's where somebody's written some SQL to do some transformations on top of the data. That means there isn't actually a physical delta table for us to page in, which means that direct lake mode can't work. So that's why you can't do direct lake on top of views. I've heard a lot of people ask, views, we've been told that's a best practice to create views on top of your source. Yeah, you're going to have to change that best practice if you're going to want to use direct lake mode. Similarly, you might have a warehouse, and you might have defined some row-level security against the SQL endpoints there, even if you're not using views. You might have defined some row-level security there. The analysis services engine might say, well, I'm using direct lake mode, but I'm doing it on a table which has got row-level security applied in the source. Well, I can't just do direct lake mode anymore because I might be bypassing security. In that situation, it will fall back to direct query mode again. So there are going to be some situations where it just can never use direct lake mode. Of course, like I said, you can still apply security in the semantic model, and in the future you'll have one security where you apply security once. So that, at least, limitation is not going to be so much of an issue in the future. There are also a bunch of scenarios where the amount of data you're working with is too large to work with in direct lake mode. Because like I said, we've still got to page the data into memory, and there are finite amounts of memory that we can work with. How much data can you load in? Well, again, how long is a piece of string? You can't really know until you've modeled your data and you've done some tests, because the data compresses differently. But there are hard limits on how much data you can store in memory. These vary by SKU per capacity. That's how it was with import mode. But if we know that the amount of data you're working with is likely to be too much to store in memory, again, we are going to fall back to direct query mode. And Fabric makes these checks when you start to run queries, when the semantic model starts to be loaded in. It's quite complicated, the different thresholds. There is a maximum amount of memory that can be used. This is a table that I've just copied from the documentation. There is a maximum amount of memory you can use, but also we look at the number of rows in a table, we look at the number of row groups, the number of Parquet files. You know, there are a variety of different things we look at here. If you're looking at the number of rows for an F64 P1, 1.5 billion rows, I think, is pretty generous. So, you know, we're not talking about particularly low limits here. But, you know, there are a variety of things that you can run into. How do you know whether you are running into one of these issues? Well, we are building some things into the product to make it easier for you to see when this is happening. Because like I said, there are a lot of people who've run into these issues without ever knowing what's going on. But there are a few things that you can do. So let's do some demos. First of all, what have I got here? Let's not save that. I've got a warehouse here, and if we look here, I have got my sales table loaded in. It's exactly the same sales table as I had before, and I've built a view on top of that. So I've got a physical table in a warehouse, and I've got a view which is just a select star. So that's pretty straightforward. And if we look at the model I've created, I've got a semantic model with that sales table and that view in it. So we would expect that the sales table is going to be in direct lake mode. The view is going to have to fall back to direct query mode. One thing that we can do to peek behind the scenes is run a good old profiler trace. So I'm going to create a new trace and connect up to that particular semantic model. And what I'm going to do is I'm going to look at the query begin and query end events. These are the events that are fired when a query starts and ends running. And I'm going to look at the direct query begin and end events. These are the events that are fired when a direct query operation happens. And I'm going to look at the Vertipack SE query begin and end events. These are fired when the engine gets data from stored in memory, which, if Direct Lake is working, that's what's going to happen. So I'm going to click load. All right, so we're running a trace, and I'm going to create a new report on top of this. So first of all, let's just get a card. We'll go to our sales table, and I'll just drag the sales column into the card. So a DAX query is running somewhere in the background, and we will have a look and see what happens. There we go, it's run. Now, you're thinking, oh, this is confusing, because I can see direct query events and Vertipack events. This needs a bit of explanation. If you look at the actual SQL that's being generated for these direct query events, what's happening here is the engine is saying, well, all right, I'm in a warehouse. Is there any security there? Let's run some SQL just to check to see if there's any security there. So we're not actually getting data. These direct query events are not proof of actual direct query mode. This is the engine saying, well, hold on, is there any security that will force me to fall back? It knows that there isn't, and this is where we see these Vertipack storage engine events. So we're in direct lake mode. That's good. However, if I do the same demo, put a card in here, and go to my view and drag that in, and I get the same result back, I only get direct query begin and end events. And if we look at this direct query begin and end event, it's a simple sum, which is exactly what you would expect to get the sum that we need for that particular card. So we can prove that that is direct query mode. So Profiler is a great way of detecting or seeing what's actually happening in the background. There are a few other things that we can do as well. I've got DAX Studio here, and it turns out there are a couple of DMVs that you can run, again, to kind of peek behind the scenes. Now, like I said, remember, there are going to be some scenarios where the engine knows in advance that you can't use direct lake mode, like when there's a view. So if you run, I've already run it here, so we can just have a look at this. This DMV called Delta Table Metadata Storages. It's a bit funny, but it will return one row per table in your semantic model. For some reason, it's not working on views at the moment, but there's my warehouse sales table. There is also a fallback reason column here. Fallback reason of 0 means that fallback is probably not going to take place for, at least for any reasons we know about in advance. A non-zero value here simply means that we've detected a scenario that will force this table to fall back to direct query mode. Again, this is a bit funky because 3 means that the table doesn't exist, which it clearly does. We just used it. It should be returning a 2 here to say we're a view. But anyway, a non-zero value is something to think about. If you're interested in finding out, how many row groups or how many rows I've got, again, there are DMVs, there are queries you can run, like, for example, TM schema Parquet file storages. That has a row group count column that will tell you the number of row groups. If you're interested in kind of inspecting the structure of your delta tables and working out whether you've hit things, there are already a lot of really helpful scripts, like my colleague Phil Seamark, who is probably here still today, has created a script called Delta Analyzer in a notebook. You can get it from his GitHub repo, and you can just run this, and it will automatically analyze your delta tables and tell you what's going on in them, and also tell you all of these different row counts and file counts and things. Similarly, another one of my colleagues, Michael Kowalski, has also got a GitHub repo with a whole bunch of really interesting notebooks in, and again, he's got some things there that will help you with detecting whether you're falling back to direct lake mode. So that's all pretty cool. Last thing to mention here is that it is actually possible to control this behavior or get some more control. So if we go back to here, if you've got a custom semantic model, and it's only going to be with a custom semantic model, and we open the data model, there is actually now a property on a semantic model, or a direct lake semantic model, called direct lake behavior mode. You can set it through a tool like Tabular Editor. You can also now set it through the model view here. So I've had to go to the model view in the data pane. You select semantic model, and you've got this direct lake behavior property here. At the moment, it's automatic, which means that you can flip-flop between direct lake mode and direct query mode. But you can also specify direct lake only or direct query only. Why is this useful? Well, let's face it, you're going to be testing your semantic model. You're bringing in data. You're not really sure whether you're using direct lake mode or not. You don't want the hassle of like running all these DMVs and scripts and so on to check to see whether direct lake mode is working. So you could set your model to direct lake mode only, which means that it will only ever work in direct lake mode, and in the scenarios where it would fall back, you would actually get an error. So set this to direct lake only while you're testing and developing, and you know whether you're going to hit those limits or whether you've done something that will force fallback. Last couple of things to mention about the internals. You will hear a lot about V-order in direct lake mode. This can cause quite a lot of confusion. If you think about import mode in Power BI has been very successful because it's able to compress data very, very well. We've had 10, 15 years of experience of building algorithms for compressing data for our in-memory column store format that we use for import mode. All we've done is taken those algorithms and transferred them to other workloads inside Fabric for creating delta tables. So we've just taken our proprietary compression algorithms and put them in, for example, Dataflow's Gen 2. So every time you use a Fabric workload to create a table, we're going to use those algorithms to make sure the data is compressed as efficiently as possible. This is something we call V-order. V-ordered delta tables are not special. They are just regular delta tables. Everybody else can use them. It's only Microsoft that can create them, though, because we own those proprietary algorithms. V-order is important, or it's one of the reasons why it's important, is that because it compresses data so efficiently, you get smaller delta tables, which means that loading the data on demand is going to be faster, which means that your queries are going to be faster as well once the data is stored in memory. So it's our own secret sauce, but it is not proprietary in terms of the structure of the delta tables. Delta tables that we create with V-order are just delta tables, so don't worry about that. We also still do have the concept of refresh with direct lake semantic models. But I've kept it to the end because it's a little bit confusing or a little bit misleading. You still need to refresh direct lake semantic models. But refresh for a direct lake semantic model does not mean you're copying the data in, because of course we're not doing that. So what does refresh mean with a direct lake semantic model? Refresh we refer to internally as something called framing. If you're loading data into a delta tables have got the idea of versioning. So you load some more data into a delta table, you append some data in, you create a new version. Refresh for a direct lake semantic model simply means look at the most recent version of the data. So it's only going to take a couple of seconds, and by default, when you create a default semantic model, it happens automatically. So it'll just do these refreshes in the background every time it detects changes, and bang, it looks like your semantic model is up to date. So why do we expose this at all? Well, if you're building your own custom semantic model and loading different data in, maybe you're updating a dimension table, and then you've got another job that takes a little bit of time to update a fact table. There could be a big difference of time in between. You don't want your semantic model to always show the most recent data in those scenarios. You want to be able to control what data is displayed. So if you're building a semantic model, you don't want to automatically have that data, the latest data displayed. By giving you control over refresh, it just means that you can say, I'm only going to refresh and show the latest data when I'm sure all of my ETL jobs are finished. But remember, refreshing a direct lake semantic model is going to be a couple of seconds, maybe maximum of 30 seconds, not that much longer. Cool. That brings me to the end of my session. And we've got some questions, I believe. We've got 2 questions. So the question is, how big is my F-SKU here? This is a trial capacity, which is the same as an F64. You can do this with an F2, but like I said, you'll want to have a look at this table to see how much data. You can load 300 million rows of data into an F2. But of course, there are going to be other things to bear in mind here. You can't load a table with 5,000 columns in and 300 million rows. It's going to depend. So you can, but you will need to create shortcuts from Databricks into your lakehouse. I can see some Databricks people in the audience. We are working on a better together story. We're friends with Databricks, I promise. I did a webinar with Databricks just the other week. We are going to have some announcements about how we work in a more friendly way with Databricks going forward, because this is a thorny question. And then I think we've got some questions at the back. I'll take maybe 1 or 2 and then maybe take them offline, because I know the next presenter will be coming in. One more question here, and then I'll pack up, and then you can queue up and talk to me later. Sorry, yeah, the gentleman there. No. So the question is, I've got a Databricks created table, and I set up a shortcut to it. What kind of performance am I going to expect? Well, it depends. You're going to want to test it. But it's not going to have V-order. It's not going to have all of the other things that we do to make sure the right number of, the optimal number of row groups and files are created. it's probably going to be okay. In our testing, people find that it works pretty well. It might be faster if you copy the data into a Fabric Lakehouse and use one of our workloads to do it, but just test it and find out. But that's me out of time. I will be packing up, and I can take some questions offline. Thank you. And don't forget to do your feedback.